Yeah, guys. So today we'll do with the important analytical functions or the window functions which are available in Snowflake. Which will be extensively used in data engineering projects, especially. So for doing a lot of data analytics, right? So we would be using these functions. So I'll be walking through some of the major important functions which will be used in day-to-day life of a data engineer. Okay. So those functions, I'll quote some examples as well. So have the queries and then I have examples. So let's look at the data and then we'll see how they are behaving. Okay. The second topic would be on the stored procedures. So we'll create a stored procedure and then execute that. And then, one topic which I thought of discussing and then I forgot it, which is on information schemas in Snowflake, right? So basically information schema contains all the metadata of the tables and all the objects, right? So that one I missed to explain, but yeah, we'll cover that as well in today's session. Okay. Yep. So starting with it, so window functions are basically it's like any other function which we use in normal SQLs, right? Like minimum, maximum, those functions like range, dense, rank, and everything. But the only difference was you can do it, at specific window level. Basically, instead of in the traditional SQL, what we used to do, like you get max of employee ID, okay, and then you need to group by on all the select columns, right? So if suppose you are selecting column A, column B in your query, and then you are applying on max of one column, you need to group by on basically on all the columns which you are having in the select, correct? So, but for window functions, you don't need to do that. You can specify group by functions, or you can, specify whatever parameters you have in the same column itself. You don't need to, group by at the query level. So that is the good thing about the window functions. Okay. So I'll take one example. Okay. So suppose think that you have, employee ID 1. His name was like, employee ID 1. Name is Prydhvi. Okay. And then what can we do? Okay, some take department. Okay, department is IT, and then 2 you have some Raj, and then admin. Okay, and then you have 3 and some other name, and then admin as well. Okay, so now these are the like employee ID, employee name, and the department. Okay, suppose you want to know how many employees are there basically on max basically max of the employee ID you need to know. In that case, what we usually do, if you select, I need name and department as well. So when you select, okay, when you select employee name, okay, and employee department from this table, okay, so including these 2 columns, okay, I'm having one more thing as group by, sorry, this one, max of employee ID. Think this is traditional system, okay, traditional RDBM is what we are doing now. Max of employee ID from employee. Now what my group by column should be? It should be all 2, right? Employee name and employee department. Else it will throw you an error that not a valid group by function, correct? So to avoid this to happen, right? Because if I group by an employee name and department, I wouldn't be getting the max of the whole records, right? I'll be getting only for IT, I'll get 1, and for admin, I'll get 3, correct? So that is not the proper one. I need to get max of the whole set which I have. So for that, specifically, we use window functions. Okay. So what we do now for window functions, now we will have max of employee ID. See here, if you guys can see here, right? Max of employee ID over clause. Okay. I don't need to partition on anything right now because I want it for the whole set, right? So what I'm doing, order by employee ID descending. as max of employee ID. So order by clause can be anything. So it is a syntax and then as max of employee ID. Now you don't need to basically group by on anything at the end, because this windowing, right? Windowing make sure is that it is calculated on the whole table or the partition what you mentioned here. Okay, so I'll what we will do is I inserted already records into this employee 2 table. Okay, so Prydhvi, Raj and Ram. So 3 things are there. Employee 2. Okay, this is the table right now. If you preview the data, these 3 records we have, whatever I'm showing up now. Just a second, guys. Instead of previewing, I can just run it. This free tier version, right? It takes a lot of time. Yeah, if you see here, this is the data which I inserted, right? Prydhvi 1, Raj 2, and then Ram 1. Okay, so now what happens when I select this employee name, employee ID, and max of employee ID? Okay, see here. So for each and every record, I get 2 because I didn't partition on anything right now. Correct? So it's like basically your order and employee ID, and for this particular set, the complete set, you're basically doing that. So that's why the reason you're getting it in this way. Okay, so coming to the next one, it is in the same way, right? Min function is also in the same way. Basically, you get the minimum of the record, okay? Minimum of the whole set, employee ID, and that will be populated for each and every record. Okay, and the other one would be rank. Rank and dense rank, you guys already know, right? So it's basically ranking based on certain things. Like here in my case, I'm ranking based on employee ID ascending order. So rank would be like since employee ID is the same, it is ranking 1 and 1, and the second, the last one would be 3, because rank would skip the intermittent one if there is a duplication in rank. The dense rank will not skip that. I think these things you already worked on, I guess, in the initial sessions of lab. So rank and dense rank, these are the differences we have. Okay, so these are certain window functions which will be used. So this link I'll share at the end of the class, guys. So you have a lot of functions here. You can it gives clearly like whether it supports Windows or it doesn't support. Okay, so some of the important things I'll be telling now. Yeah, these ones. Okay, the first value first value, last value, lag, lead, and these things would be mostly used. Okay, so first value, what it tells, right? So whenever you're grouping on something, right? Suppose take this data set. Okay, take this data set. What it is basically, now it has ones in column 1, column 2 it would be 10, 11, 12. Okay, and column 1 has 2s. Think this as employee IDs or like whatever you have the other column. Okay, now this is partition by column 1. As I was telling, you can partition on some column, right? If you can partition on column 1, out of this partition, take the first value. So, and you can specify the order to column as well. Order by column 2. Okay, by default it will be ascending if you don't define anything. Nulls would be last, so it means that put nulls at the last. Okay, now what happened? I grouped by column 1. Okay, order by column 2. Column 2 is 10, 11, 12, and null would be last since you specified that. Out of this set, take the first value of the column 2. That's what you're telling. See, first value of column 2 over partition by column 1, order by column 2, nulls would be last, and take this as the column 2 first. What is your value now? 10 would be your value. Okay, this particular thing, where would you use, right? In suppose think that there are set of transactions it got inserted. Okay, in live scenario, guys, where we use this extensively, right? So I'm telling you guys that scenario, we have a lot of transactions. Okay, and then out of those complete transaction set for particular account, right, I need to know what would be my latest update timestamp for that complete set of transactions. In that case, we use this function. Okay, we group by on account ID. Okay, account ID, and then we usually what we do, sort based on the update timestamp or the insert timestamp, create timestamp of that record, and then we take the minimum of that, basically the first value or the last value, right? That gives you min and max. So minimum of the timestamp or the maximum of the timestamp. So in that cases, we use these functions, first value. Okay. So yeah, you can play with it, you can change partition columns, you can order by in the reverse way, and then do all those things. It all returns based on your data set. Okay. So guys, you understood, right? Why first value used and what this function exactly does?
Yeah.
Yeah. Okay. The same way, last value. Okay, so last value will also does the same way, but it gives you the last value in that particular set. Take the same example. Okay, you have partition by 1. Okay, and you ascend you're sorting it based on the column 2, then taking the last value. In this case, my last value would be 12, so I would be getting 12 here. Okay, so to make sure you don't get nulls in your data set, right, based on your function, have nulls first or nulls last. Okay, because your data set might contain a lot of nulls in your data set. Think that there is a scenario that you have a lot of nulls in your data, and you shouldn't get that as your first or last value. In that case, make sure that you have nulls first, nulls last option included when you're picking up the last value or the first value. You got that, right? If you're taking first value, put nulls last, and do that vice versa when you're using last value, so that you don't pick nulls every time. You need to make sure of that. Okay.
So like by default, it's at its place.
Sorry.
So by default, if we don't like in this query, there are no nulls last or nulls first, then it's gonna be at its place.
So in this data set, they didn't include nulls, for understanding purpose, but by default,
Yeah, like so for example, where it is the first partition, column 2 value is 12, let's say over there it is null, and we put null first or null last, then it's gonna be null.
Correct. Yeah. It's gonna be like that. Yeah. Nulls will always be at the top. When you order by, right, it will be at the top. So when you're taking first value, it will be problem. When you're taking last value, that is fine.
Yeah, I mean, I got that, but that's what I'm trying to say. Like, even if we order by, but if we didn't do nulls first or nulls last, then it's gonna be at the last by default. Because
correct. Yeah. So specifying that would be at the safe side. Okay. So majorly for the first value, you should be doing that. At least for the last value, since it goes at the minimum level, so that's fine. But for the first value, you should be specifying nulls last. Because if you don't do that, when you sort based on that field, if you have nulls will be at the first every time. I mean, at the basically at the last, this one, last value, at the minimum value as you specified. So, yeah. Okay, so we need to make sure that we take that every time. Okay, and coming to the next one, lead and lag. Okay, so lead and lag.
Excuse me, sorry. Can you go back to that last value? To the last value.
Okay, function. Last value. Okay.
At the syntax, yeah. In this one, we don't really have a table. We are just defining values from values clause over there.
Correct.
So like it is selecting column 1 and column 2 as like a dual table.
Correct. It is doing in that way. Yeah. It basically it considers this as the insert. Okay. And then it considers this as column 1 and the column 2.
Okay. Sure.
Yeah. It's like querying on the go, right? So
yeah, that's what I was thinking. I just wanted to confirm.
Yeah. So coming to the lag and lead, right? Lag basically what it gives, it's the same way how you sort it in the same way. Okay, I'll take this example. Okay, so 1 minute, guys. Yeah. I will take this example. Okay, so select column 1, column 2. Okay, lag of column 2. Lag basically gives you the previous value. Okay, suppose you are considering this row, 4 is my record now. It gives you 5 in place of 4. You got it right. Again, as this 4 record, it gives you 5. So when you give lag of column 2, it gives you the previous value, and it all depends on how you order your column. So when you order by column 1, now for 4 you'll get 5, for null you'll get 4, and for 2 you'll get nulls. Nulls would be skipped anyways. Okay, ignore nulls is the condition which we are giving. So when you give ignore nulls, nulls would be skipped and you get the previous value. So basically lag, what it does, it gives you the previous value for each and every record. So for this record, it will give you the value of the previous record. For this record, it will give you the previous record. When you consider null, right, for this record column 2 which has 2, previous record is null. Since you have ignore nulls, it takes 4 as the lag value. Did you guys get here? So here, since we have 2 nulls, for the 6th you'll get 2 everywhere. So for all these 3 you'll get 2, because null it would be 2. This null you're ignoring null, so it will be 2 again. And for this 6 you're ignoring 2 nulls, so it should go to the next preceding value, so it should be 2. Guys, so this especially, sorry,
I got that, but my question is, let's suppose it is very highly unlikely, but let's suppose if their values above 6, which is the very last value of column 2, are all null. In that case, what it would return?
It will be null. It will be null. See, in the first value, if you see, right, the 5, okay, 5 doesn't have any value above that, right? So it will be null by default.
Yeah, but I mean, as it is written over there that all rows except the first contains non-nulls. My question is, if in the column 2 right there, if all the values are null except the last value, which is 6, in that case, what would it return?
Even then it will be null. Even then it will be null, because you don't have any other value, right? And you're ignoring nulls. So it doesn't find a match, and then it doesn't find a lag value. It will be null.
No. Okay.
Yeah. So that would be the thing. So basically why we use this, guys, so in case you need to get the previous value, the only way we can do it is using self join. Correct? Using self join, you need to order by and then do something to get the previous value. So Snowflake has this functionality so that you can get your previous immediate value. There will be some certain conditions, cases, right, where you need to copy your previous value. Suppose think that, okay, think a situation, okay, so you need to daily get the account data. Okay, think that you have certain accounts, okay, and so today you got 100 accounts, and tomorrow even from the source, if you get one account, I need to copy all the data from the previous account. Okay, suppose think that for this one account, okay, I got the data from source, and for all the 99 accounts, I'm not getting certain fields like address or anything like that. Okay, I'm not getting address, you think. Okay, so what I would need to do in that case, I need to copy the value from the previous record. There is a requirement in that way. Copy from the previous record and put it to this record. So in those cases, we would be using this instead of using self join, right? So if in the traditional SQL, what we used to do, if we don't get this, I mean, if I need to get the previous record value, there is only other way. I need to look up on this table once again, like joining to this, or else you need to, give in conditions, like where this record, where this account ID in this table or something like that. Instead of doing that, there is one thing to search to the previous record and get the value. You cannot skip and go to the other one that is present in the nth value, I guess. Yeah. So this is the function which it has, where you can get the nth value basically. This is the only way you can get skip and go to the second or third row. You cannot go using lead or lag. The only way is to ignore nulls and you can go, but you cannot go to the like third or fourth record. You cannot iterate over those ones. You can only get the previous record or the next record. Okay, so lag gets the previous record, lead gives you the next record. So in the same example, right, let's go over this one. So 5 will give you 4, 4 will give you 2, and nulls you are ignoring anyway, so this also will have 2. So for all these 3 you'll have 6 here, and if you see 6 is the last value, so you'll have null over that. So lag gives you the previous value, lead gives you the next value. If you want to skip and go to some level, you have to use nth value. There is one function called nth value, you need to use that. Okay, so these are the major functions which we might be using, we'll be using extensively, guys. So please make sure that you have this you have this hands-on on the lab. Okay, so have multiple options. As someone asked question now, right? If you have nulls everywhere in the previous values, try those options as well. What happens exactly? So whatever questions you have, you can try in Snowflake. It is just the preparing data set and then executing that, right? So try executing multiple functions and then see how it is behaving. And when you go when you're working on live scenarios, you'll be able to correlate and then use them accordingly. If you don't experiment, then it would be difficult and you wouldn't be getting the exact function at that time, what to use at what scenarios. So use that. Okay, and row number is one of the thing which we again use it extensively, basically to find out the minimum value. Minimum basically I meant when you're sorting something and then getting the minimum record. Okay, so this we use it basically for finding duplicates as well. Okay, I have one of the example for finding duplicates, right? In the live scenarios, we might be seeing duplicates in records. Okay, suppose think that your employee table, okay, now you have only 3 records, you can do this manually. Okay, by seeing employee you can tell this is duplicated. So if you have millions of records and you don't know what got duplicated, okay, so for that what we usually do, right, select the employee ID, okay, and the count of star, okay, from employee to group by employee ID having count of star greater than 1. So now we used having clause, right? Having clause is used in these cases where you want to filter the data set after executing some query. So in that cases we use this. So here what would be the output now? Hello, guys, are you with me?
Yeah, Prydhvi.
Yes. Okay. I don't know, some issue with Zoom. Yeah. Okay. So now if I run this query, I would get employee 1 because it is repeated twice. You get this. Okay. So look at this SQL clearly, guys. So we are selecting employee ID, count of star from employee table, group by employee ID. So employee ID is my primary key. I need to group by this to check how many duplicates are there. Duplicate IDs are created. So I'm just having clause where count of star for each and every employee ID, I'll get count, right? How many the times it is repeated. So we are getting that and I'm checking if it is greater than 1. So whatever is greater than 1, it means that it is duplicated. So it's more than twice. Okay, so this way we find the duplicates. So whenever you find a scenario, I mean, for data projects, right, this would be used everywhere, like finding out the duplicates, finding multiple values, like, you might be having multiple columns as well here. Like right now it is only employee ID which we took as primary key. You might be having composite keys as well. You might be having employee ID, employee name, group by on top of that. Okay, so those scenarios also might be there. And yeah, so I have one more scenario as well, guys. Okay, you can try this in your lab sessions, right? I'll tell you that you can note down if required. Okay, so I just need to know, okay, you have employee table and the department table. Okay, so in employee table, think that I have some 6 records, 6 employee records. Everything is unique, guys. Okay, I have employee IDs from 1 to 6. Okay, in department table, I have only departments related to 5 employees. Okay, suppose think that I have employees 1, 2, 3, 4, 5, 6. Okay, in employee table, but in department table, I have 1 department would be IT, 2 would be admin, blah blah blah, until only 5. Okay, 6 one is missing in the right table. Guys, are you clear with the scenario? You have 6 employees in the employee table and 5 employees related details in the department table. Okay, now find out which employee doesn't have department. Don't use in conditions or not in conditions in where clause. Don't use this. Don't use where clause and find out that. Use joins and find out how can we identify that one account which doesn't have the record in the department table. Are you guys clear with the question?
Yeah, so basically there are 6 records in the employee table and then 5 records in the admin table. And we need to find that one record who is not assigned as admin. Is that the question?
Correct. Yeah. Don't use where clause to find out where this employee ID not in this table, where employee IDs are in this table. Okay. Use joins or whatever logic you can, right?
You can use left join.
Yeah. Anything which is, which is like you feel that it is best, right? You can use that. We'll discuss in tomorrow's class, like how I mean, what approaches you have and which is like best sequel. Okay, because why I'm telling we shouldn't use in and not in, guys, because this operation would be costlier. When you're searching for each and every record, you go and iterate over millions of records, is costlier operation. You shouldn't be doing that, right? So for that reason, I'm asking you guys not to use this. Okay, you use whatever you have in your mind, and then we'll see which one would be the best approach. Okay, yeah, you can use joins, you can use anything, like whatever thought process you have, try using them, and then find out how can we do that. Okay, yeah. So any questions till now, guys? In the window functions, where would we use these ones, or any other practical scenarios you need? Or are we good to go ahead now?
So like in the question, there will be 2 fields, right? One with employee ID, the other one with user access or something like that.
Employee ID and the employee name, you can take that.
Okay.
And here employee ID and the department. Employee ID would be the common key between both.
Okay.
Yeah. Yep. Okay. So going to the next topic, right? So stored procedures. Stored procedures stored procedures are something like, the functions which are created in Snowflake. These are custom functions which can be executed. It can have multiple, multiple statements included in it, or like, whatever queries you execute step by step, right? Everything can be done in stored procedures. So these are like any other object you create in Snowflake, and it is like you need to call the stored procedure whenever you want to, execute it. So that is the way stored procedure works on. And a stored procedure is completely on the JavaScript. Okay, so I'll be walking through on these things. So the usual syntax, right? Like, you need to give the variable MySQL command. SQL command, what you need to, this is the variable name. Okay, you can give anything you want, and the command what you need to execute it. Okay, and statement one would be create statement of this SQL command, and you need to execute this. This is the sequence of executing commands in stored procedure. There might be multiple things ahead of this. I'll show you guys, but this is the overall skeleton, right? You create a command, okay, assign it to the variable, and you create a statement for that command and then execute it. This is the sequence you do usually. Okay, so how many ever commands you have, create a variable to that, you need to create a statement to that and execute it. This is the thing we do. Okay, so for that, what we are doing now, this is the syntax to create the stored procedure. Okay, create or replace procedure and the procedure name, open and close brace. Okay, what kind of return statement it has. So I'm returning float here, and it is not null. Okay, language would be JavaScript, as start with $. This is the syntax of it. Like you're telling it starts here and ends here. Okay, and where MySQL command, give the SQL command what you need to execute it. Okay, and for after each and every statement, you need to end it with semicolon. That is mandatory to make sure that is the line separator. Okay, and where statement one equal to, as I told you, as we discussed here, right? So we are creating and then executing it. The same thing would be done here. Okay, and once this is done, so there is one loop which is set here, like we were getting column 1 and column 2, and then they were returning it. Okay, so in the same way, I have one sample statement. Okay, so which is like SQL command. Okay, so one more thing, guys, like when we are executing stored procedures, right, exception handling is the major part which you need to work on. Okay, why we need exception handling was, suppose think that, okay, you have some 5 statements in your stored procedure, like insert statements. Okay, you are inserting into some table, creating some table in between, and then you're again reading that from reading the data from that table, and you're performing multiple operations. Okay, think that out of 5 statements, it executed 3 statements, and 4th statement got failed. Okay, now what happens when you re-trigger this? Suppose think that the 3rd statement is creating some table. Okay, when you execute this once again, there might be some problem with the data, right? You might be updating something in between, and then you again, if you re-trigger, there might be some problem if you start it from the scratch again, like SQL statement 1. So you need to resume it from 4th one. Only then your job would be success. There is some business use case like that. In that cases, exceptional handling plays a major role. Okay, exceptional handling, what you can do, you can execute all the 5 statements in try block. Okay, in catch block, make sure you roll back that. Okay, so once this try is done, at the end of the try, make sure you commit the data, as we did for transactions, right? In the last class, when we executed transactions, we started with begin, we executed multiple statements, and we did a commit, right? Commit or rollback. So it is in the same way. So whenever something fails in between, you either roll back or you commit the data at the end of the try block. Okay, and also this would be useful in logging purposes as well, guys. So if there is some failure in in the try block, as we know in the other programming languages, right, when some error in try, catch gives you that exception, you can print that error basically. So that is why the reason, especially we use exceptional handling in the stored procedure creation as well. This is very important to use exceptional handling, or else you will run into issues having that part of the sequence be executed, part of those will be skipped, and then you need to go and resume your batch would be difficult. So that's why the reason we use this one. Okay, so in my example, I used that. So one of the SQL command what I have is create or replace table employee copy a select star from employee. So I'm just creating one table, that's it. Okay, so I'm creating that statement and then executing it. Okay, so at the end of the try block, I'm giving where result equal to success, and when there is a failure, we give where result job failure. Okay, now let us do with the success scenario. Okay, I'll create the stored procedure, create or replace stored procedure, function create employee clone successfully created. So this is my stored procedure, right? So this is created now. So for calling stored procedure, this is the way we call it: call and the stored procedure name. So if you give this, it will call the stored procedure. It will tell you it is success. Whatever you print here, right? In the real-time scenario, what we do, right? In the current, scenarios, what we are working on, how we do was in when we are returning result here, right? We include write count, read count, error count and everything, all the parameters which tells you that it is success. We include everything for auditing purposes, basically. So suppose think that in your stored procedure, you're reading 10 records, okay, and you're joining with some tables, doing some union operations and all, and you're finally writing 20 records into the target. Okay, that is what you're doing in your try block. So at the end of the thing, what we do was we capture all those counts, right? So counts, how to capture the counts, it is simple, right? So select star from that, we create a view on top of that input data. We just give select star from that count of star from that view. That would be my read count. However you do in programming language, you can do everything here. Create variables, declare variables, assign some values to that variables, use that variables in your further steps, do everything whatever you want. There is no sequence related to executing that. So assign counts to certain variables like read count, write count and all. At the end of the message, when you're returning success, give read count, print that count, give write count, print the count. Message, print clearly the message, don't put just success. Give that this block has been successfully executed, or the stored procedure has been successfully executed, data got loaded into target table, give the table name. So that is how we need to give the messages in stored procedure to make sure that it worked fine. Because guys, the problem was like you don't have debugging technique here. Only through log messages you would be able to identify at what step it went and where it got stuck. Okay, other than that, you cannot run in debug mode and then run through SQL by SQL and then see what is happening exactly. So the only way you can identify whether it went to try block, whether it went to catch block, whether it is success, failure, it is only through messages. Okay. And also you might be having multiple exception blocks as well. So right now I have only one try and catch, right? You might be having multiple things. In first try block, you might be inserting into one table. In second try block, you might be inserting into second table. So like that, you might be having multiple try and catch blocks, right? So your messages in catch and try should be differing in that way. Okay. So now, right now, if you see, I'm just assigning, catching that error and then printing this error. Okay. When you're doing, you have multiple try catch blocks. Make sure that for each and every catch block, the message is different. Okay. Don't put just job failure and the error message. Make sure you differentiate this. So while inserting into this particular employee, so I can have the statement here, right? So failure in creating employee clone. Okay. And then I'll put error. What is the error? I'm printing it. Okay. Now think that I'll remove this one. Oh, sorry. This would work, right? So I'll remove E from here. Okay. Now see, execute the stored procedure and see what error it returns you, what message and error. See the error, guys? Failure in creating employee clone. Error. Till is what your string is. Okay. After that, error from Snowflake. When you give this catch the error, this ERR is basically from the Snowflake. This can be anything, guys. ERR is like a variable. You can catch anything, like ER can be there, anything. This is just the variable. Okay. So SQL compilation error, object employee does not exist or not authorized. So it's two-way problem, right? Even if you don't specify this, there is a problem. If you don't print this also, it's a problem. If you don't print this one, you don't know what Snowflake is throwing exactly. You only know that it went into catch block. You don't know what error it was. So make sure that both your custom message as well as the message from Snowflake, both are printed in your catch result. Are you clear, guys? Yes, no?
Yeah, I am.
Yeah. Okay.
Yeah, me too.
Yep. So now think that there are already stored procedures created in the system, and then you want to get this, DDL of that. So this is the way we get the DDL, right? So are you guys aware of this statement, get DDL statement? How to get the DDLs of tables, procedures, and all the objects in Snowflake? Are you guys aware? Are you
No.
guys aware of this? No. Okay.
No.
So get DDL, what this function does, right? It takes the input. This is the object type, what object type it was. And when you give the object name, it gives you the DDL of that. DDL is basically what? The create statement of that particular object. So in my case, I'm searching for the procedure. So when I run this, I get the complete DDL. See, whatever we executed here, I'm seeing here now. Create or replace procedure, this one, execute as owner, these things, it automatically, assigns it as where SQL statement and everything. You see whatever we executed now, this complete statement. Okay. In the same way, if you want to get some DDL of a table, give get DDL of table. Okay. Yes, you just need to give table name, employee 2. This gives you the complete create statement. So this you can use in your so usually why we get these DDLs, right? It would be easy to execute in your further environments. Like suppose you're working in development environment and you're now going to your the further environments like testing, UAT, production and all. So get all the DDLs like this for each and every table, so that it would be generic across, and then use this in your further environments to create the objects. Okay. So now if you do this one, you got the DDL, create or replace table, this one with all the fields. Okay. And there is something called information schema. Are you guys aware of this as well? Information schema or not? So, okay, I'll take it as no. Okay. So other than demo schema or the schemas what we create, there is one schema which is present in Snowflake, is information schema. So this information schema will have details of each and every object. Okay, what you create in Snowflake. It is columns, applicable roles, database, okay, external tables, file formats, functions, everything. So you can query like this, select star from information schema dot tables. This will give you all the list of objects. Okay, suppose think that I need to find something related to employee. Okay, now what you need to do, where table name equal to employee will give you this particular data related to that particular table. Okay, table name equal to employee. Okay. Yeah, if you see here, so employee table name, okay, is transient, no. So since it is a permanent table, right, it is not transient table. So you have row count, you have retention time, you have all the details for that particular table. Okay, is insertable yes, is typed yes, commit action null. So all these things, auto cluster no. So these things, everything, you will have the details of that particular table. If you want to see columns, you need to give columns here. Columns is one more view, right? So if you give the columns here, for each and every table, you'll see columns here in the column view. So for each and every column, what is the position of that column, whether it is nullable, data type of that. So each and everything you'll have here. How many columns it has, what are the sequence of it. You'll have all the, what is that like constraints on the tables, what column has nullable, which is primary key, everything, all the details. You can see it here. So like that, you can see for pipes, procedures, and everything, functions, everything you can see. Okay, functions also, if you give preview data, right? This, so we don't have any functions created. So pipes we can see. Okay, pipes, if you see, okay, so pipes also, I think I've deleted it. Yeah. And table constraints. Yeah, table constraints is one of the view where you can see what constraints are there. It's not happening. Let me 1 minute. Okay, we didn't define any constraints probably, so that's why the reason. Yeah, table privileges, data might be there. Yeah, if you see table privileges, we gave a lot of privileges, right? So grantees, who is the grantor, what is the privilege you have. So these guys like
sorry to interrupt, actually I kind of lost in between. Can you please explain what exactly the JavaScript is doing? I wasn't able to follow. I mean, I get that it has the DDL constraints. Going,
okay,
but,
okay.
What exactly is showing?
Yeah.
The query.
So what we are exactly doing was you're assigning one statement. This is SQL statement what you're trying to execute in the stored procedure. Okay, so it can be anything, guys. Like it can be a select command using multiple joins or anything. Right now I'm doing create or replace table. It can be any SQL command. Okay, so we are assigning that to a variable. Okay, what I'm doing, I'm giving create statement command so that it prepares the statement. This statement is nothing but the SQL command what we gave here. Okay, that I am assigning it to a variable now. So this variable would be calling an execute function to execute this particular SQL command, create or replace this table. Okay, so this is the sequence order. Like whenever you are executing some statement, first assign this SQL query to that variable, create statement, use create statement to compile. Okay, and then execute it to execute it. You have execute method, so you can call this variable dot execute. This will execute the query and then store the result set here. Okay, so that result set, what I am doing now, I am returning result whether it is success or the failure. So exceptional handling, as I told, right? So I have try block. Okay, try block, what it does, it basically tries everything in this inside this. Okay, if there is a failure in between, what it does, it immediately goes to the catch block. Okay, so this exceptional handling is present in all the programming languages. So what it exactly does was it tries everything in this block. If there is a failure in between, what it does is it goes to the catch block and prints you whatever is there in the catch block. Usually in the catch block, we print the failure message. We usually print the failure message, or if there are any connections open, we close those connections and all. So right now, since this is Snowflake, we don't have any connections, right? So what we are doing, we are printing the message. What was the failure? Why was the failure? So I'm printing one custom message as failure in creating employee clone. Okay. Error would be my error message what Snowflake threw. So Snowflake is throwing this error message. Okay. At the end of the code, I'm returning the result, whether it is success or the failure.
But this procedure is only gonna run once, I guess, because it is not like whenever the new data is coming into the employee table, we are copying that data or creating a new table and saving that data from the employee table.
No. Stored procedures are like functions. Okay, these are standalone functions in Snowflake. This should be called using either Spark code or any other ETL tool. You need to call these ones as how you call the other functions. Like count, how you're calling, you need to call in the same way.
Like the only thing I'm not getting in here is, I mean, I understand that we are saving the SQL command of create or replace the table employee copy, and we are copying everything from the employee table into a variable called MySQL command. But then why we are saving that MySQL command into a variable statement, and then after that we are storing that statement or executing that statement into a variable called result set. Can't we just do all that in one step?
No, you cannot do that. See, this can be skipped. Okay, you assigning to a variable can be skipped, and this command directly we can give it here. Okay, but the way we do that, execute and create statement should be done in this way. You need to create a statement, you need to execute that. So this is the way what to tell this. The functions work actually. First, you need to create the statement. Create statement is basically the prep work. Okay, so it is to get the syntax and do everything. So these are all create statements and all. It is internal functions which Snowflake has. So whenever you give the statement, it compiles everything, and then it gives you if there is any error. Okay, only then it is compiled properly, it executes it. So that is why the reason these things should be followed as is. How we follow in Python or any other programming language, right? So I mean, I don't know, guys, like in any language, when you connect to database or like, when you're performing some operations on database, this is how we do. We create a statement and then execute it. You don't directly give the command and then push that to database. So this is how you create the statement, execute it. You create the statement and execute it. That is how you do. Okay. So this command right
is
now,
it necessary that we do it in JavaScript? Like we have defined language JavaScript.
Sorry, I didn't get you.
So you have defined JavaScript as a language. Like, to have JavaScript, or can Snowflake have any other languages in this? Like create
stored procedures should be in JavaScript. Yeah.
Okay.
It supports JavaScript, so it should be there.
Okay.
That. Yeah. And one more thing, guys, like right now it is only create or replace table command, right? So this can be executed manually as well. I don't need a store proc for this. So since this is just an example, we have this, but there will be a lot of sequels here. Okay. It is not that only you create or replace one table, you use stored procedure. There might be certain set of sequels, like you use CTEs, okay, with commands, and then you create lot of views. At the end of the job, you join the views and then create one data set. Everything can be done. Okay, this would be the cleaner approach to make sure that, see, if I directly make the statement, I mean, I copy this one and put it here, you'll have a lot of things here, right? Inside these braces, you'll have a lot of SQL statements. So to avoid that, what we usually do, we assign complete statement to one SQL, this variable, and then use that in the create statement to avoid confusions. Or to be a bit cleaner, right? We use that. You can replace this variable and directly put it here. It's fine. But to look cleaner, this is the best approach or the suggestible approach. Assign a variable to the SQL what you have. Create the use create statement to create the SQL and then execute it.
Okay.
Yeah. Any other doubts, guys, in stored procedures?
I'm good.
Yeah. Okay. So yeah. So then, I mean, how to call is this one, right? You can use this statement as you call like any other SQL statement. You can call it from any tool, any ETL tool, or you can directly run it in Snowflake, or you can run it through Python code, Java code, anything. You can just you need to only run this statement, and your stored procedure would be executed in Snowflake. That's all. Connect to Snowflake, execute this statement as we are doing right now. Okay, so get DDL command is basically to get the DDLs of any object created in Snowflake, either it might be table, stored procedure, views, or anything. Okay, and information schema, this is very important, guys. When you're working on the real-time projects, information schema you'll use a lot of times to get the structure of the table, to see what privileges it each and every table has, what grants it has, and you might be running into a lot of issues like you might not be able to access that table at that time. Instead of reaching out to admin asking what privileges it has, you yourself can see what privileges that particular table has, and then you can tell them that my user doesn't have privilege, or you can easily understand, right? If I simply go to that, you'll see what privileges it has. And if you see here, right, just take a particular table, employee table. Okay, so it has delete insert. Suppose think that you don't have the delete privilege and you're trying to delete something. By seeing this, you'll be able to at least understand, right? You only have insert, select, update a privilege. You don't have delete privilege on it. So we can just ask them, grant me delete privilege so that I can, perform that operation or something like that. So make sure that you, whenever you create or you're doing something in the lab sessions, make sure you go to this information schema and see how it is reflecting, what privilege you gave and how it is reflecting there. It is most important to understand whenever you're creating some objects, privileges are also equally important to make sure, data is not shared across, or you have proper control over that object. So that is most important thing. Okay, yeah. So this is about information schema. Information schema is most important thing. And you guys know about describe table, right? This you guys might be knowing it. Describe table, table name. These things you know, right? Yeah. So this one gives you the same details, but at the each table level, right? So whether it is null, primary keys are not there or not, and all the things, but with the less amount of information schema will give you a lot of things actually. So this, see, if you see right side, we have a lot of things, what type it was, what scope, and all those things. So yeah, so it gives a lot of information. And so describe table is there. Then what else important things we have? So stored procedures is the most thing. Yeah, granting permissions to stored procedures, right? How we granted permissions to tables and views, in the same way we give grants to the procedures as well. Like grant all on all procedures in schema name to role developer. You guys know that syntax, right? How we grant this one. Let me take one of the example here. Yeah. Yeah, if you see, yeah. So if you see this one, right? So it is like grant all on procedure. Okay. This procedure name to role, what role you have, what role you are going to give privilege. It is in the same way, guys. There is no change to that. So however you are treating other objects, treat this also in the same way. So it is like one object in the Snowflake. So whatever permissions you need to give, you can give. Execute permission, delete permission, read permissions, and all you can give. So usually in live practical scenarios, right, what happens, read privilege will not be given to everyone. So whenever you give get DDL of that particular procedure, that wouldn't be given to everyone. The reason being, the stored procedure, whatever you are creating here, is the original business logic what you want to execute. Correct? Like you are joining on some tables, getting some fields and inserting those fields, doing some transformations. So that's the business logic, the core business logic, right? So if everyone in the project sees that, that might not be the proper security approach, right? So that's why the reason for most of the people in the project, you will not have read permissions. You cannot get DDL of the stored procedure unless you have an access. So the stored procedure, anyways, you will be creating it in, storing it somewhere in Git or somewhere in the real-time projects. But from the database, you cannot get using get DDL. So they'll give grants in such a way that you will not have read access to that. And execute access would be there only to the application. So if some application, right, you are running your job through Spark. So only Spark application will have access to executing the stored procedure. Normal regular developers will not be having access in the higher environments like production, UAT and all. So that kind of grants they would be giving to the stored procedures, because stored procedures is different from all the other objects, right? This, you will have the core business logic written there. So that should be more secured when compared to the other objects. So yeah, so whenever you want to edit some stored procedure, it is in the same way. You need to get the DDL of this, modify the SQL, and then recreate it and keep the grants. to make sure that it is executable by any other user. Okay, so this way stored procedures are created and then executed using JavaScript. Yeah. So any questions till now, guys?
I mean, I just wanted to know if you can, on a high level, explain how exactly we use a stored procedure, execute a stored procedure using PySpark.
Sorry, I didn't get you guys. What is that?
So I was asking if you can kind of explain how we use these stored procedures using PySpark.
So I'll do that in the next session, guys, when we start with Spark Python, right? I don't have code handy, so I'll execute this stored procedure and then show you guys. It is like executing the SQL how we did, right? Earlier, like create or replace table. It is in the same way. Like we just need to call the stored procedure. So I'll tell you guys in the next session for sure.
Okay.
Yeah, we'll execute one the stored procedure sample one and see. It's like creating any other, I mean, running any other SQL command, connecting to Snowflake and executing this. See, ultimately, you're executing from PySpark or Python standalone code. It is like you're connecting to Snowflake and executing those commands in Snowflake, right? So whatever commands you are executing right now in the terminal or the worksheets, you can do the same thing there as well. How we did select star from the table on the previous day, right? On the Python code, the same way you can do this as well. But we will show that. Yeah, we'll see it in the next session when we are walking through. Yeah. Yeah, and any other questions in the previous session, guys? Like you tried installing integrations and all, right? So are we good with it, or do you have any doubts still?
I think we are good with it, but can you provide this script so that we can do this assignment in the practice session for the practice and lab sessions?
Yes. I'll attach it right away, guys.
Some hands-on on this with the JavaScript store procedures.
Sure. Yeah. I'm doing it right away. Where is this document? Yep. 1 minute, guys. Let me save this. I just added one more thing to it. Yeah, so I added two links in the above these guys. So one is for analytical function and the other one is stored procedures, that documentation of Snowflake link. So you can go through these and all the queries, whatever I used there, everything are here. Okay, and let me add the both this one as well. 1 minute, guys. So let me add these two other statements as well. Get DDL and information schema. You guys don't know this as well, right? So yeah, can you guys check once if it is downloadable? Did you guys download?
Yeah.
Yeah, Prithvi.
So it's available, right? Okay. Yeah. Okay. So so any questions of as of yesterday's session, guys, or no? Everything looks fine. Yep. Okay. So I'll take it as no. Okay, so I want to discuss some of the things related to guys, like performance related things, right? In Snowflake, especially when you're working on too many big queries and you're working with millions of records in it, there are certain methods to be followed before you're writing your queries, and there would be some best best approaches to do. So I'll be discussing on them. Like the first thing would be, whenever you're reading some data, filter it as much as possible. Okay, so suppose think that you have table A, okay, and you're joining it on table B. Don't just join both the tables. Before that, filter the data. So from table A, you might be having as per the business situations or something, there might be active and inactive records in your tables, right? Everything in the table might not be useful for you. Out of that, millions of records are like history, like 10 years, 15 years of data. You might be having only data, you might be requiring only data related to last 1 year, 2 years, or 3 years of data. So try filtering the data and then do the joins. Okay, so when you perform joins, right, it is basically, if you have 10 keys in your left table and 10 keys in your right table, it tries to join on each and every record. So when data is not necessary and if you're joining, it might be taking a lot of time to query. So first thing, thumb rule would be filter the data as much as possible. Not only for joins, any data when you're querying from tables, underlying tables, filter as much as data possible as per the business requirements or as per your knowledge, right? Based on the table, if you see the data at the table, right, you might be understanding what kind of what are active records in it, and what kind of data we need to filter based on audit timestamps, or latest created records, or however, like what it takes to filter the data as much as possible. Okay, and second thing would be, don't use inner queries anywhere, subqueries basically. So select star from, and then give inside that, give select star from these joins and all. Don't do that. Use joins instead. Okay, so suppose think that you are joining employee table and employee 1 table and 2 table. Okay, on top of that, you want to select some more columns from this table, or you're again joining on one other table. Okay, as I told you guys an example, right? Don't use inquiries, not inquiries. In the same way, don't use subqueries. So this scenario, whatever I told you guys earlier, right? This can be achieved using select star from this table. Okay, where employee ID not in, again give select star from admin department table. That can be achieved using that, but you are using inner query there. And for each and every record in your source table, it is going to match against the target table. And that's like, if you have millions of records, you're again matching with millions of records in your target table, which is like, too much of operations. So avoid as much as inner queries in your commands. Don't use inner queries at all. As per my suggestion, don't use at all. Use joins wherever required. So that's why the reason I gave you an example, right? Think cloud. Think how can we do using joins without using subqueries. Subqueries are restricted, guys. Don't use that. It is going to make your query run longer than usual. Okay, and use Snowflake cache as much as possible. Okay, you know that, right? As I was telling earlier, like if some queries run, the data Snowflake stores the data for 24 hours. Okay, so use that functionality, and as much as possible query from the same table. Okay, if you are using multiple times multiple queries you are using from the same table, use same query everywhere. Like suppose like you are selecting 3 columns from the table, you did it in your first query, this one, 3 columns you selected. Okay, next time when you are using this table, if only 3 columns are suffice, use the 3 columns itself. Don't add 4th column, because the data is already cached in Snowflake. When you run the same query again, it will get it from cache, rather than again going to table, query that 4th column, even if it is not necessary. So make sure that if you are querying some table, at the start of the development itself, you fix the table. Like suppose that table has 10 fields. Okay, now I'll tell you one use case, right? Table has 10 fields. Okay, 10 fields in it. Okay, you have your project of like some 3 SQL queries you have to run. Okay, SQL query 1, SQL query 2, SQL query 3. So output of SQL query 3 will be your final output. Okay, so think that from this table in SQL query 1 you are using 3 fields. Okay, in SQL query 2 you are using 4 fields. In SQL query 3 you are using 5 fields. Okay, now what happens, right? Don't query multiple times, like use 3 fields here, use 4 fields here, use 5 fields here. Don't do that. Create a view with maximum fields, how much ever you have. Okay, if it is even if 10 fields, it's fine. Create a view on 5 fields, which is the maximum thing we saw in our scenarios, right? Use that, create a view here. Okay, so that even if you query this 100 times, Snowflake will get it from cache, because this is already queried once, and how many ever times you use it, it queries from here, and it should be very quick. If you query 3 fields here, 4 fields here, 5 fields here differently from the same table, if you do that, here it takes 2 minutes, here it takes 2 minutes, here it takes 2 minutes again. So you are querying same table, it is taking overall 6 minutes. Did you guys get this scenario, what I'm telling? Yeah. So create a view, or else do that select on the first SQL itself with all 5 fields, whether you use it or not. That will be used again in the second subsequent SQLs. So it takes it from the cache rather than going and reading it from the table. It uses it from the cache. So you should think big, right? Out of box actually. Don't just get the requirements and then do only which is pertaining to this SQL and go to second SQL and do whatever it has. Don't do that. If there are views or like same SQLs used in the multiple times, create a view on top of that. That would be pretty easier, or like it would be very quick in Snowflake. Okay, make sure you understand the underlying functionality first and then go ahead and do the coding. Only then you'll understand, you'll code it best actually with the best practices. Okay, so this is one of the things which you need to keep in mind when working with Snowflake. Use as much as the best functionalities it has to make it perform better. Okay, and so joins is one thing, this is one thing, and union and union all, right? Union and union all, use union wherever required. Okay, if you don't want duplicates and all, use union. Union all gives you all the data irrespective of duplicates. So when you are doing self joins and have multiple records in it, some things, right, how we do, you use union all. Okay, you know that duplicates are not required, you use union all. At the end of the queries, you use distinct star. This is not required, right? Instead, you can simply use union here itself. You don't need to perform distinct at the end. No, distinct is not required at all. Simply give select star, because this union anyways will, when you're unioning both the tables, it will anyways remove the duplicates. So when you go to the end, you don't need to do distinct. You guys understood, right? How I'm approaching to this? Use union all and use distinct. It is like you are performing 2 different operations, and the result would be same anyways. But you are giving Snowflake 2 different commands, and here it sorts the data, compares with the previous record to find out the distinct, and here also it does the same. Instead of that, do distinct here itself. I mean, keep union here itself, and distinct would be avoided here. So you are saving a lot of time there. So this kind of minor things would make a lot of difference when you are writing big queries, like 100s, 200 lines of queries in Snowflake. This makes a lot of difference. So make sure that you use genuine functions, or which is as per the requirement. Analyze the data, guys. That is the first thing you need to do before even you run into code. Analyze the SQL, analyze the data, underlying data, what it has. Perform the SQL on top of that based on the data it has. Don't do based on the requirements. You got it right, what I'm telling, or any gaps here?
I'm good.
Yep. Okay. So these major things you need to keep in mind. So to get all these things are done, first you need to understand the functionalities of union all, distinct, inner sequels instead of using subsequels, what we can do, all those things you need to, whatever we discussed in our classes, make sure that you get knowledge on them. Basically get, rather than getting theoretical knowledge, right, how we explained in our classes, get the practical knowledge, like how this is extensively used, how where it is used exactly, what scenarios it is used. That's where it makes the difference, right? Now I'm showing you this example. If you read count, I mean, if you get the concept of count differently, having differently, you cannot make them together. It would be difficult. Now, if you see this scenario, right, this is used to find the duplicates in the table. So now you know the application of it. Okay, to find the duplicates, we are using having, count, and all. So in that way, you need to explore the things and then work it on. Okay, so this is the major things. So Snowflake information schema is the most thing as we discussed today, and analytical functions, go through all the analytical functions as we discussed. These are the major ones which we used in data engineering projects, lag, lead, min, max. Okay, and coming to the stored procedures, that is one of the important topic as well. Creating the standalone functions in Snowflake, which can be called using any other ETL tool or any other connectivity tool to Snowflake. Yep. So yeah, any other questions, guys? I think today it would be the end of Snowflake sessions. So any questions from very first day? Do you guys have any questions in how we handle these scenarios, how we do that, how we do this? I mean, we can take as and when we go, right? It is not that we end up here, but yeah, we can take these questions in further sessions as well. But if you have any other questions, we can discuss now.
Prydhvi, where did you share the recent document which you shared?
In Zoom, right? In Zoom chat.
Oh, chat, I don't see that document.
Did anyone download? Someone told they downloaded it, right?
Yeah, we got it.
Yeah, if required, I can share it once again. You can download it in chat. Yeah, I shared it once again, guys. Or if someone has it, you can share it internally, please, so that everyone has access to that. Did everyone get that?
Yeah.
No, I don't see that in chat, but I don't know where.
Oh, it's in chat. Is it with everyone, guys, or you guys are able to see that?
I can see
We're
that.
able to see.
Yeah, we downloaded.
I can see that.
Okay. Okay, then if you can share it with everyone, right, it would be great, guys. Yeah, again, Srajan share to everyone. Okay. Even I was able to see what Srajan shared. So, yep. So that's all I have for today, guys. So any other things you have in your mind, on top of your mind, or you need to go to lab sessions and do something and then come up tomorrow?
Actually, so the only thing left for me is try to do load the data from S3 in Snowflake. I have not done that.
So once you
I've been watching the video. I mean, since we got access to the videos today, I didn't have time early this morning.
Okay. So do that as part of today's session, tomorrow's lab session, right? Because there is nothing more to do with this, window functions and all. So you can try that out, that S3 integration. So see, once integration is done successfully, guys, it would be very simpler. Like you just need to run the copy command. But make sure that if that copy is not working, make sure that your keys are same. That external ID, whatever I was showing on that day, right? It is same between Snowflake and whatever you have in the trust relationship JSON file. Make sure that both are same. Only then it will work. Okay. Still, it will show you that integration is done. But when you run the copy command, you might be seeing a failure. Okay. If that external IDs are same between both, you should be able to copy the data.
So I tried to do the copy command, but I'm not getting an error, but it says like copy executed with 0 files processed.
So give the file name properly. Did you give that force command? Force equal to true on that day we were seeing, right?
Yeah, I did not give that.
Yeah, give that because this is enforcing that option. If you give this, it would work, because on that day also I was facing the same issue, right? Before the session when I run it worked for me, and after that it was not working. So give force equal to true, guys. Make sure that is given so that it will work. It should work. Chitra or someone, who was the question?
Veena. Yeah, I will try that.
Yeah. Okay. Veena, yeah. So you can try that option. It would work definitely if you give force. Yeah. So yeah, if any other question, guys? If not, I'll stop the recording here.
I'm good.
Okay. So stop recording.